we're first going to talk about how to stop a thread by using a so-called volatile flag. And this is an approach that we actually use in our Palantiri simulator app when you press the cancel button. So this way is the first way, and in some ways the lightest weight way to stop a Java thread. And here's the more detailed example that I summarized earlier. So we're going to define ourselves a Boolean called m is stopped, which we initially set to false, and we make this a volatile. And as you undoubtedly recall at this point, because we've talked about it many times, a volatile is used to ensure that changes to a variable are consistent and visible to other threads atomically. And what we're going to do to make this work is we're going to make a little helper method called stopMe, which is a so-called mutator method. And when stopMe is called, it's going to set the m is stopped Boolean field to true. And essentially, you can think about volatile as being a critical section for setting fields or setting variables. Now, unlike a normal critical section that we've been seeing with things like synchronized statements, synchronized methods, reads and writes to a volatile variable will spin rather than block because it's very lightweight. And it's basically equivalent to an atomic test and set operation. Now, we're also going to define convention that we're going to use here. So within the run hook method for the myRunnable class, we're going to have a loop that will periodically check the value of the m is stopped flag, and then will stop running when m is stopped transitions from false to true. So some long-running operation will then periodically check to see if it's been stopped, and if so, it'll basically break the loop and go ahead and stop. The thread will exit. The way we stop in this case is we're going to just fall off of main, but of course you could do other things, or fall off of run rather, but of course you could do other things as well. You could throw an exception or whatever you want to do. So what are the pros and cons of using a volatile flag? Well, the pro is it's super duper lightweight. It's just basically a check using a volatile field. What could be faster? That's super duper fast. The downside, however, is that these volatile flags aren't integrated into the Java execution environment in a transparent way. So, for example, if we were to do a call like a wait call, which is, you recall, moved us into the waiting state of the thread from our earlier discussion of the Java thread state machine, then the Java wait method knows nothing whatsoever that we've got this flag called m is stopped. And so we can be setting m is stopped all day long, but if this thread is blocked in a wait, it's not going to wake up because it knows nothing about our volatile flag. So that's the downside. You can make systems very non-responsive because we haven't fully integrated the way of stopping them with a volatile into system calls that are blocking in the Java virtual machine or the Java class library itself. As a consequence, these blocking operations won't be awakened in any timely way, and therefore that will impede shutdown processing. So it could be a very long time between the point where we are sort of, compulsively or neurotically clicking the stop button and when the program actually shuts down. You may have no connection whatsoever. It just is whenever that wait call decides to wake up. So that's the end of the overview of how to use a Java volatile to stop a thread. And now we're going to transition to other ways of doing it that are a little bit more heavyweight, but also a bit more predictable as well.